Hey, welcome back. Today we're going to look at graphing trig functions, and this will be our first little introductory lesson. And I want to graph a sine of x, and I also want to graph cosine of x. So we'll do that to start. So maybe you can give it a try if you want first, and then after we'll do cosine. But one thing I'd start with is really thinking about what we're looking at. So I'm going to, for my x values, I'm going to input an angle, right? If we think about back on our unit circle and maybe drawing one briefly could help. I'm going to put an angle in. That's on my x value, and we'll do it in radians to practice our radians. And I'm going to get out some y coordinate, right? So my output is going to be how high I put it on my graph. So let's start with 0. So if I'm at 0 over here, 0 radians, and on my unit circle, I was at 0. So what's the sine of 0? Well, the sine of 0, that y value in my unit circle was just 0. So that's actually the first point on my graph. If I move over in between pi over 2 and 0 is pi over 4, and maybe I'll label it just to remind us. And so if I put in the sine of pi over 4, what's that? Well, at pi over 4, we know both x and y are both root 2 over 2. One thing I wrote over here, things to keep in mind, all these questions that we're going to do, and we'll do the reciprocal functions and tangent also, knowing the square root of 2 is about 1.4 and that the square root of 3 is about 1.7 can really help us plot a little faster. So if you kind of think about these, the square root of 3 almost makes sense, right? If the square root of 4 is 2, well, the square root of 3 is going to be a little less. That's at least the way I think of it. And then we know, I just mentioned root 2 over 2. Well, where's root 2 over 2? Well, if I knew root 2 was 1.4, well, divide by 2 and get about 0.7. So when I put in sine of pi over 4, I'm at about 0.7. Maybe it's about there. Then it doesn't have to be perfect. I guess it would be a little less if this is 0.75. But again, we're just estimating here, just trying our best. Let's put in sine of pi over 2. Sine of pi over 2. Well, if I'm up at pi over 2, what's my output? What's my y value here? Well, it's 1. So we'll plot 1. Let's continue along here. Oops, how was that 1? That was not 1. I went way too high, sorry. All right, so I'm at 1. Let's put in 3 pi over 4, right? That's in between pi over 2 and pi. Well, at 3 pi over 4, I get the same value as before, right? That y value on my unit circle is also root 2 over 2, which we said is about 0.7, right? Which should, again, be a little lower, both of these, but just estimating. How about sine of pi? Well, now when I'm at pi, my y value is back to 0. And I'm going to keep going around, and you're going to start to see a pattern here. If you put in 5 pi over 4, you're also going to get one of those root 2 over 2s, but this time it's negative, right? Because you're in your third quadrant. So I get negative 0.7. And then if I go down to negative, right, territory down here, if I go to 3 pi over 2, I'm at negative 1 this time. And continue along, I get that same value as before, that root 2 over 2, but again, it's negative. And lastly, when I'm back at 2 pi, what's my sine value of 2 pi? Just 0, right? So I get this really nice looking curve here, like an ocean wave, and it continues forever. Let's go back a little too. How about if I put in the sine of negative pi over 4? And maybe you can already guess, I'm just going to go backwards and get some of the same values I did before, right? Sine of negative pi over 4. Well, I'm back here. I just got negative root 2 over 2 earlier, right? So I'm going to have 0.7 again. If I put in negative pi over 2, right, going that clockwise direction, I get back out negative 1. And if I continue along on this merry path, I'm at, again, negative root 2 over 2. So I'm back at that 0.7. And you can kind of see this pattern. It's about to repeat. And so if you want to separately plug in each of these, if it's your first time, and look at where negative pi is, and oh, yep, it's at 0, you can. But this pattern is going to continue. And so if you need a little more time to plug those in, go for it. I'm just going to kind of plop them down so we can talk about some other things together. Sorry. Bad connecting of the dots. All right, so here's a rough example of what the sine curve looks like. And it's this nice rolling periodic function. And let's talk about briefly domain and range. Write your domain, and I'm going to do it sloppily. Always write the domain and range in whatever form your teacher wants it, whether it's like that set builder notation or interval notation. All right, domain. Is there anything I can't put into my function, right, my inputs, anything stopping me from putting in like something in between here or something really negative or really big? No, right? So your domain is going to be all reals. And again, put it in whatever format your teacher wants you. And how about my range? What's my output of the sine function? Well, my highest output is 1, right? I can't get anything bigger than 1, and I can't get anything smaller than -1. And think about our unit circle also, right? -1 and 1 were our biggest values. So your range is from -1 to 1, and there I skipped to interval notation, right? From -1 to 1, and the brackets mean inclusive, right? Including the ends. If I had, just again, a random reminder, if I had parentheses instead, that would mean not including the ends, right? Exclusive. That's not what we have. All right. Let's take a look at what cosine looks like. And again, why don't you pause, see if you could give it a try, and then come back and check with what I'm going to do. So again, maybe I'll just draw a brief unit circle just to kind of keep us visually remembering, right? My input, now when I'm graphing, is an angle. Well, other times too, but when I'm looking here, I'm putting in an angle, and I'm getting out, I'm plotting, even though, yes, on my unit circle, cosine, we were talking about the x-coordinates, but when I'm graphing, I'm putting in one of my x values on my graph, which are my angles, and I'm still going to get out an output, right? A y value for my range here. So if I'm at 0, right, if I put in the cosine of 0, right, what do we get for my output that I'm going to plot on my y-axis? Well, I get the x value of 1, right? The cosine of 0 is 1. So here, instead of sine where I started at 0, I'm starting at 1. All right, let's continue. Let's go to pi over 4. Well, the cosine of pi over 4 is similar to sine root 2 over 2, right? At that 45-degree angles, I get the same answer. So this time I'm at 0.7, and maybe I'll do a better 0.7 this time. It should be more like this. Oh, looks like it might be going down first. How about cosine of pi over 2, right? Up here, 0, right? Cosine of pi over 2 is 0, so now I'm at 0. Cosine of, keep going, 3 pi over 4, right? I'm over here. Same thing, right? Root 2 over 2 again. So I'm at root 2 over 2. Oh, except I was looking and saw this is weird. Be careful. We're talking about our x values. Maybe that's why instead of skipping it, maybe write out the whole answer so that we don't make a mistake, right? If we're talking about our x values, those are negative here, right? In our third quadrant. So I have a negative root 2 over 2. So that's negative 0.7. And when I'm down at pi, well, what's your x value there? It's -1, right? So I'm at -1. And I might come back up if I kind of think about the pattern with sine last time. Maybe they're related. If I go down to cosine of 5 pi over 4, again, negative, right? Your x values are negative root 2 over 2. So I am coming back up. And if I go down to, all the way down to 3 pi over 2, what's the x value there? 0, right? Coming back up. Keep going around. You're at another root 2 over 2, right? Another 0.7. This time it's positive, right? X values are positive on the right of the y-axis. And if I put 2 pi, I'm back at 1. All right. This time it kind of looks, I know a lot of my past students, when we first did this, said it looked like bullhorns. Give you a little hint where it goes next. It does go down. Let's go the negative direction. How about cosine of negative pi over 4? All right, you're going to get the same values, right? Now I'm going over here. Well, we already got that it was positive, root 2 over 2, right, 0.7. Let's continue along. Well, this is the same values before, right? I'm at 0. And same over here, another root 2 over 2, but I'm negative this time, right? I'm in that third quadrant. Keep going along. I'm back at pi, or negative pi in this case. I'm at 0. Oh, sorry, not 0. I'm x values. I'm at -1. Right? And so if you continue this pattern, you get this same nice curve out. And so I'll connect these. Not an artiste, okay? Wow, I'm getting really bad here. Sorry. All right, and there's cosine. And so we talked about domain and range for sine. Let's talk about domain and range for cosine. Domain. Usually we do domain first. My inputs, anything I can't put in. Is there any angle that blows up everything? No. There's no way to get a divide by 0 or something, right? So your domain's all reals. And your range, is your range any different than sine? What's your highest value and your lowest value? -1 and 1, right? Nothing comes out higher than -1 or lower than -1 or higher than 1. Whoops, I forgot the actual 1 there. So that's very similar to sine. It's the exact same domain and range, and the curves kind of look similar. And we'll talk today, we didn't change anything, amplitude or frequency, what we'll do, but eventually we'll start playing with those and we'll see just how related sine and cosine are. Hope this helped. Thanks for watching, and please subscribe to After School Extra Help. Also, leave a comment if you'd like more examples or if you want another topic to be covered.